All right, everyone, welcome back. This is video number 2 for the exercise testing 1.5 mile run. What I'm going to do in this video is go through the sample lab report that you will be getting shortly. Actually, by the time you get this email, you will have already gotten it. This will help walk you through what's required of you on the lab, okay? Now, keep in mind that the report does not have to be exactly as it is here. This is just an example of a decent grade of the lab report. Make sure that you don't copy the text word for word because we will notice, okay? Alright, so this is the cover page. Should look something like that. You can put your name and my name on it just to kind of avoid confusion. So below here, put your name and then TA Robert Lewis, okay, and the date down there. Table of contents, alright? Table of contents is imperative. I will tell you that several people get points taken off for the table of contents because they don't review the pages that correspond with the categories, okay? So once you're all done and you put your table of contents together, you might go through and make a change that will bring one table down one page. So instead of on page 3, it's on page 4. That's probably the first thing I look at to take off points. So that's a nice little hint there for you. Make sure that that's correct, okay? The other thing that you're going to want to do, make sure that there are page numbers. Page numbers on every page. I prefer the page numbers on the bottom. You can put them on the top, though I won't take off points for that. On the sample lab report, there's a statement of purpose and objectives for the lab report, for the laboratory. Excuse me. Go ahead and don't do that. Okay. Methods and procedures. This, however, I do want you to do, but I want you to do it in your own words, okay? So if you look in this example report, methods and procedures, you're going to see a lot of like ACSM, VO2, and mLs per kg per minute, horizontal running equation, blah, blah, blah. I don't want to know that stuff, okay? Basically, I want you to be able to tell me in about a paragraph that you understand what we did, all right? We took subjects out and we ran a little bit over 1.5 miles in order to get the VO2 max of the individuals. VO2 max was measured in mLs per kg per minute. This can be done because we use a regression equation that will estimate the subject's VO2 max. Something like that, okay, in your own words. Obviously, even though I say in your own words, I do want it to be well written. So make sure no TMI, LMAO, I don't know, LOL, let's get this started type stuff. Keep that out there, okay, or out of it. Basically, for this report, and every report in this class, you want to make it as dry as humanly possible. No emotion whatsoever. Don't make it like a magazine article where you're trying to entertain your audience. You basically want to try and put me to sleep while getting the point across. Okay, that's how scientific writing goes. Tables 1 and 2 on this, you don't need to put that in. That's redundant. It's just included. There's no actual data in here, okay? As long as you're obviously going to have to look at these to derive your different values, okay? Okay, then we get to the results section, okay? So for now, all right, these are not included. Before the results section is going to be the methods. Give me a paragraph or two on that. And then you're going to have the results section, all right? Notice how the tables are formatted. You don't have to format them like this, but it's good to omit vertical lines. Make sure the vertical lines aren't in there. Other than that, color's cool. You can do different formats as long as it's easy to read, okay? The other thing I want you to pay attention to, and I'll totally notice who watched the videos and who didn't by the people who do this, okay? Every category, okay, needs to have units if it applies, okay? Age, for example, on this person I would have marked them off a couple points because is it age in months? Is it age in days? No, it's age in years. You have to indicate that. So you can put YRS or YR, even Y, okay? Time in minutes, observed VO2 max. Now here's another point off because they didn't put mLs per kg per minute, okay? And then VO2 max, age predicted. And again, we want mLs per kg per minute on that. FAI you don't need to worry about, okay? So that is a nice little tip to keep your points upwards of 100, okay? And then you're going to do the Cooper classification. Let's actually talk about the table briefly. This is and I'll do another video and show you how to get these values using Excel. But basically, Table 3 classifications according to cardiovascular fitness level for males. All right, so you're going to have all the males from our class, and you're going to put their age, you're going to put the time that they ran, observed VO2 max, age predicted VO2 max, FAI, and I did another video on FAI, so you should know how to do that on everyone as well. And then the Cooper's classification. Okay, now notice down here, on every table you do for my lab reports, you want a mean and standard deviation included. All right, that's pretty easy to do in Excel. I'll show you how to do it later. Okay, Table 4, exactly the same thing, but for females. Easy stuff, right? Table 5. Table 5, and keep in mind, this might not be Table 5 because Tables 1 and 2 I told you to take out, right? So really this would be Table 3. T-test, 2 sample assuming equal variances. All right, I will show you how to do this in Excel. If you have a Mac, it's unfortunate because for some reason they don't allow the data analysis tool pack included in the Excel version for Mac. Okay, so you'll have to find an alternative stats program or go to the computer lab and use a PC. Okay, as we continue to scroll down, we have a relationship here. Okay, 1.5 mile run, or let's read it up here. Male VO2 max versus 1.5 mile run time. Okay, so down here we have the 1.5 mile run time in minutes, and this person did a boo-boo. And what might that boo-boo be? That's right, they didn't put the units on the y-axis. Okay, so how am I supposed to know what that is? All right, make sure on this axis it's VO2 and mLs per kg per minute, or VO2 max and mLs per kg per minute. Okay, and I'll show you how to do the graph a little bit later. It's actually very simple. Okay, under the graphs, this is how I want you to explain what's going on. Okay, so you can put the explanation of the graph under the graph. So figure 1, scattergram for males versus 1.5 mile run times. It seems a little bit redundant, so if you don't put that and you have a good explanation in the title, I won't mark points off. Okay, these are the values that you're going to need to get: r squared, 1 minus r squared, pi, and SEE. Okay, I'll show you how to get those on another video. But once you get those, okay, list them like they are here, and then below I want you to explain what each of them mean. Not what the individual statistical score means, or excuse me, not what the actual statistic means, but the actual score. Okay, so for this example, an R value of 0.987 represents a very high negative correlation. Okay, now you'll notice here's another boo-boo. Says very high negative correlation, but they didn't put a negative up here on the R value. That's a no-no. Make sure that if it's a negative R, you put the negative there, and one way to determine that is if this relationship is negative. Okay, if this relationship goes down instead of up, it will be negative. All right. This is the same thing for females, so I'm not going to talk about that. And then you get to your discussion. Okay, so that's all the data that needs to be processed for this. Don't get me wrong. There is going to be some work involved with getting those things put together. Again, plan on 4 hours. If you're working with a partner or group, it might take you less. Discussion. This is a fairly good example of how your discussion should be. So when you look over it, you read through it, take notes. Okay, don't take notes, but try and do something similar. In the discussion, basically I'm looking for you to explain to me what happened using your data, and then interpret that. Okay, so if the females had a higher VO2 max than the males, for example, why might that be? Okay, you can give me your hypothesis for why that might be, and then you can also search some peer-reviewed articles online. You go to PubMed or go to Google Scholar and look, female VO2 higher than men. Probably won't happen because it doesn't exist unless the female's really, really fit and the male is highly unfit, which could happen. Okay, but anyway, so you want to get some literature to back that up. This is how I want you to cite everything. Okay, so it's the last name of the author, Hawkins et al., 2007 with the year. Okay, and make sure it's before the period. As we scroll down, you're going to see that her discussion is very, very lengthy. I don't need it to be lengthy. Like I told you in discussion in class, 3 to 5 pages. If it's over 5 pages, I'm throwing it away. No, well, not the whole thing, but I just X out the 6th page and I don't read it, okay? So make sure you have a nice intro paragraph. You get right into the data, okay? You explain the data.